Good morning, everyone. We are Team 986, and we are presenting the Smart Waiter Bot. So our main goal is to help assist the waiters in any average restaurant in providing or distributing food to the customers. Our main thing is that we want to lessen the burden of the waiters so they can provide better customer service. So my main role was doing the April tag, so I was one of the software developers. My name is Lolith. This is Vishnu, and that's Aryan. We're the software developers. They work mainly in the SLAM and the ROS. That is Kunal. He's a team lead, and he worked with the electrical components. And this is Hiba. She was the mechanical design of the team.
Okay, so I'll be talking about the mechanical and the electrical aspects of the bot. So I'm going to start from the bottom part of it. So that's our chassis. We're going to go with the peanut chassis. It's a pre-built chassis that we can get. It's 14 inches by 14 inches, and it can hold up to 100 pounds, which would be more than enough for what we're trying to carry. And we expect the bot to be about 2.5 feet. If we can make it taller, that would be better. And then moving to the next layer, the black part of it, that's where we're gonna house all of our electrical components, the batteries and everything. And moving to the top is our tray. This should be able to hold at least 2 plates and about 15 pounds of food and plate weight. And then on the top part of it is where we're gonna house our sensors. So we're gonna go with the cameras, Raspberry Pi camera, and they're gonna be used for our April tag detection, and that's how the bot identifies the table. And on top of it, we're going to go with the RP LiDAR, which we would be using to construct for mapping the room and to navigate from one location to another. And the way we're approaching this is we're trying to compartmentalize all our different layers just so if one thing goes wrong, it doesn't take down everything else with it. And now I'm going to hand it off to Aryan to discuss the software.
The robot, so the Smart Waiter Bot utilizes robot operating system and April tags to do most of the software processing. And we designed our bot to have 2 different phases. Well, the first phase is calibration phase, and the second one is runtime phase. During the calibration phase, it utilizes simultaneous localization and mapping, SLAM, which scans any kind of room, saves its data, and records it, and we can work with that data for our future part, which is and then after SLAM, it utilizes the sorry I'm choking out, but it utilizes SLAM and April tags, and April tags are used for
They help detect so we're using the April tags to put near the tables, and we make the robot scan the room. And if it sees an April tag, it detects, okay, I have to go to this table and deliver the food, basically.
It's like a verification.
Right.
Yes, it differentiates different tables so that the bot never has any issues identifying where it is.
And April tags are essentially like better QR codes that can work in any kind of condition with better angles and worse lighting conditions. And for the second part, which is the real runtime part, it utilizes the SLAM, collected SLAM data, and the April tags data, which is implemented into the SLAM data. And the integrated data is used for the robot, and it delivers food from the kitchen to the table, and then be able to return, and while always avoiding dynamic and static obstacles.
And 2 questions now.
Is it runtime 30 minutes? You talking about battery?
Yeah, so right now for our initial testing, we're going to go with SLA batteries. There are 12 volts and 18 amp hours. And we're going with that for the cost. And later on, we might want to go with lithium polymer, but they're much more expensive at the same capacity range.
That requirement is just, let's say, 30 minutes battery backup, or to make it more clear, get the word about.
Okay.
Can it adapt in real time if, for example, the SLAM data needs to change? Like, say, someone walks into the restaurant, parks a bag next to his table, and then this route is completely
That's
blocked.
the best part about using SLAM. So how it works is it can be any room, it can be any kind of restaurant, which is what we're going for, any average kind of restaurant. And while we're doing this, it also runs an collision avoidance protocol, which is also a package of ROS, and any kind of dynamic obstacle, like putting in a bag or a person walking in front of the bot, it will be able to avoid that using a D-star algorithm, which is also a part of the ROS library.
How much food is it able to carry?
2 plates, like you mentioned, like about 15 pounds.
So is that, so that's the capacity?
Net
Weight
capacity for
capacity?
just the food.
Just the food.
So the customer takes it off of the robot when it gets to their table?
Yeah.
Yeah.
All right, let's thank the team.